Okay.
That this is the lighter grill is switched on. Actually, I will take it for a quick.
Yeah, go for it.
That also has stuff. So, hello everyone. I'm Thomas Schwinge. I was already co-organizing this dev room last year, and this year I'm joined by Mark Pulhis and Jose Marchesi, also GCC developers. We're happy to be here again. We're happy to again do this in the same room with LLVM like last year. We just switched around, or FOSDEM switched us around, I don't know. That's great. The room is full right from the beginning. That's also great. I guess that's also to attribute to the upcoming fun talk. We already... You'll do that. Right, yeah, thanks for coming. GCC is alive, I guess. People use it, otherwise you wouldn't be here. There's work to be done, obviously. Other compilers also exist. They are also great. We benefit from each other. That's great. If you want to work on GCC, talk to us people here. There's not only LLVM work, but also still GCC work. Right, so, yeah. What do I need to say? Nothing else, I guess. A joke? Just in case the speaker wouldn't show up.
Oh, man.
Okay, but I still have 3 minutes to fill. Do you know a compiler joke?
No.
That's nothing to joke about. That's fair. Okay, did I miss anything? I guess I didn't know. All right, then we will get set up and start 5 minutes past 3.
Okay.
Yeah, we still have the 3 minutes to wait.
Okay, that's fine.
plugging in the laptop?
Oh, yeah, that's a good point. I should probably do that.
That's something you can do right now.
Oh, great. Oh, okay, okay.
Just works.
Oh, that's a European.
I'm sorry?
That's a European Dreamcast.
Oh, yeah,
Was
yeah.
that on purpose?
Yeah, no, it wasn't. That was an accident, but I'm glad you said that. I'll pretend it was.
Actually, I still have to introduce you.
Okay.
Yeah, well, I guess I can do that already. Introduce the next speaker, or the first speaker, actually. Or no, we will wait because the live stream should pick that up. FOSDEM is strict about the timing. Also, well, I can mention that in the meantime. We had how many submissions this year? 20 something.
Wow.
Yeah, again, same problem as last year. We had way too many submissions to handle in the room. We would have loved to give the speakers, well, you have a long speaking slot because we, but the others we had to cut them down a number of minutes because we wanted to again present a good overview, a range of things that people are doing in GCC and GNU tools generally. So that's a great problem to have. When you organize this dev room, especially the first one last year, we had no idea if we would get 3 submissions or maybe just 2. Or, well, yeah, we got 20 or something. That's great.
You need a bigger room next year.
Wow. Bigger room, yeah, like every dev room. Okay.
Sure, the microphone's working. It doesn't come on. It's only
Yeah, it's only on the recording.
Oh, okay.
Yeah. So you
I'll speak up.
speak up.
Yeah, no problem.
He's American, he can handle that. All right. Yeah, oh, it's 5 past. We should get started. So, Falco Girgis, again, talking about Sega Dreamcast stuff with GCC. Last year he had some Fortran or whatever code running on the Dreamcast. Let's see.
Now it's what have we done with it?
Aha.
Is the theme.
Okay.
Okay, so I'm here on behalf of the Sega Dreamcast community to talk about a lot of the stuff that we're doing with GCC. I was here last year, and last year was kind of getting infrastructure set up and getting a bunch of new languages on the Dreamcast. This year, I'm happy to say that we've done something with them. We've done a lot of stuff with them. First of all, what is a Sega Dreamcast? It was a 6th generation console, not a 5th one, not like Nintendo 64. Hear that a lot. It was to directly compete against the PlayStation 2, GameCube, and Xbox, which came out a little bit later. It launched Q4 1999, and then it was discontinued, I guess it's not up there, March 31st, 2001. So it had a very short lifespan, and it was considered a commercial failure, as you'll see. But it doesn't mean anything to us. It has a Hitachi SH4 CPU, and that's what links us to GCC, as you'll see. That's why we're here. GCC was the only compiler that ever supported the Super H architecture, other than a Hitachi-specific one for a small amount of time. And nowadays, everything's done on GCC for SH. There's several communities that still use it, and there was a forum post about asking if LLVM would be interested in the backend, and they said, no, the Super H is a toy architecture. So they're right about that. You'll see how cool the toy is. Has an Imagination Power VR 2 GPU, which is the previous iteration of what wound up in the iPhone, actually. So that whole line, the Power VR from Imagination, wound up hugely successful in mobile. It had 16 megabytes of RAM, 8 megabytes of video RAM, proprietary media format called a GD-ROM, but as you'll see, it can still read CD-ROMs. That's why we're able to do homebrew on it. It came online ready with a built-in 56K modem. Nowadays, we have hardware mods that will let you dial into a Raspberry Pi, so you don't actually have to use dial-up anymore. And then even the memory card is cool. It's a 128 kilobyte capacity flash 8-bit microcontroller visual memory unit that also has its own homebrew scene. So this was the year 2001. What happened? So this cool platform, Sega forsaking consoles to focus on software. Sega quits the Sega Dreamcast. Sega scraps it. Sega to halt Dreamcast production. This thing died, and basically nobody cared about it for a long time. But if you read the news now, this year, That's what it looks like. And how did this happen? We were covered by Digital Foundry the other day we ported Grand Theft Auto 3 from the PlayStation 2. Well, from the PC. It was originally on the PlayStation 2 to the Sega Dreamcast. We're going to go into that. We've had a bunch of other really exciting, successful ports. We were covered by Hackaday. Duke Nukem 3D was what impressed its creator that we ported it to the Dreamcast. And yeah, we've had a lot of fun this year. So believe it or not, people still make Dreamcast games and Dreamcast homebrew, and people port all kinds of crazy stuff to the Dreamcast because it's actually pretty powerful, but it's still embedded. I think that appeals to a lot of people. And it just has a whole lot going for it, and it's an entirely open ecosystem too, as you'll see, that kind of draws people in. Why do they do it? Like I mentioned, I think the same kind of audience that likes Raspberry Pi development or embedded systems, I think they're drawn to this because it was very powerful for its time, and it's still pretty powerful. And as you'll see, we're doing a lot of stuff on here that maybe has no business running on a Sega Dreamcast, but we do it anyway. And as you'll see, it works out pretty well. You can treat it kind of like, on the lower end, you can treat it kind of like a weaker PC. On the higher end, you can optimize for it and go to town on it and get really impressive results. At this point in time, we have, thanks to you guys, modern compilers and tools. So part of the appeal is you can develop for this extremely retro platform with modern GCC 14.2.0, as you'll see, and be on the bleeding edge of that stuff. We're in Compiler Explorer, believe it or not, which makes it fun. I don't even remember x86 assembly anymore. I just look at Super H. And that's how we optimize a lot. As I said, you can run custom code with no modifications on this thing. That's how it got extremely popular, is you can just burn a CD and play it. Nowadays, we have SD cards, we have hard drive mods. There's a little bit more that you can do now than just burn CDs. Has cool toys and peripherals, has light guns, it has maracas, it has fishing controllers, just a lot of fun toys with it, and it has, at this point in time, a pretty thriving homebrew community, and so does the memory card. So this is a run-through of our SDK that I work on. I'm a contributor to it. It's called Callistios. It's been around for about 20 years, but it didn't start to get really good until a lot more recently and draw people in to work on it. It's pretty much a custom mini operating system. It's a unikernel. Technically, I think it's considered a library OS. You link to our kernel, and by default, your applications are in kernel space, which is both good and bad. You can do some really fun stuff with it, with C++20 and kernel space, and yeah. We sit on top of NewLib for file I/O, date time, libc kind of stuff. We also implement a whole lot of libc and POSIX APIs ourselves, just because the more complete our API coverage is, the easier it is for people to target our platform, the more ports we get. We have a really good virtual file system where you can just use C standard file I/O or C++, and it just works. And depending on your virtual path, it can go to the memory card, it can stream off the network, etc. We have IPv6 stack on it. We have drivers for almost everything the Dreamcast has inside of it, hardware-wise. We have texture tools, asset utilities, stuff like that. We have a whole bunch of examples that are how I learned to program in general, actually. I grew up using the examples. That's how I learned C. So now I work on them. It's kind of cool. And then we have add-ons and ports. Like, if you know OpenGL, legacy OpenGL, you can code for the Dreamcast. We have that. We have SDL. We have Raylib. We have OpenAL. We have a pretty rich set of libraries. Obviously, the higher up the abstraction chain you get, the more you're sacrificing performance, and there's a trade-off there depending on the kind of game you want to put on there. But I mean, we have game engines written entirely in Lua that are just interpreted scripts that are pretty cool, and games written with those. We actually had a game jam, and we had 24 submissions this year, and several of them were written in Lua by people who have never programmed for like these embedded retro consoles before, and it was accessible enough that just someone writing Lua scripts for like, I don't know what engine, Love 2D or something, they could come over and be productive and contribute to a game jam and release a game for the Dreamcast. I thought that was pretty cool. Our tool chains, that's the version of Binutils 2.43.1. GCC, we have 14.2.0 is currently what most of us are using, although we have a preview toolchain configuration that's just always on the tip of 15 that we make sure that no one breaks anything or that everything's good, and everything looks great right now. GDB 15.2. In terms of language support, we have up to C23 partially supported. Basically, in terms of core language, whatever GCC supports is what we have on the front end. Partially C++ 26. We have very good standard library support for both of them. We have, from last year, you might know that we have like standard async, we have threads, we have coroutines in C++, a lot of really powerful things. We have Objective-C, but we have yet to complete our foundation port. We have someone by the name of Luna actually began work on Callistios bindings to D using the GDC front end for the D-lang, and that's pretty cool. And then we have Rust to some extent. It's a work in progress, and there are kind of two ways you can use Rust on Dreamcast, but I'll get into that. This is my Dreamcast setup yet again. I just want to share it. It's a little special. I've modded it for 32 megs of RAM so that if I'm profiling a game that's like close on the RAM limit and I need a little bit of extra RAM and wiggle room, and some people are trying to get stuff on the Dreamcast that they just need more RAM to start with. Even if you're not in 16 megs yet, it's nice to not just crash or throw an exception on out of memory or return null from malloc. That's why that's pretty cool. Mine has a hard drive. A lot of people are doing that now. You can have that with the disk drive. I have an Ethernet adapter. That's how I stream stuff off the network, and that's how I generally test. I submit binaries over the network, and it's got a bootloader that will play the ELF off of the network. I have a custom BIOS, custom fan, custom power supply, and I plug it into a Wi-Fi wall outlet so I can have this thing ready to go on my Jenkins build server that will turn it on automatically and run CI on it. So, yeah, a little crazy. Like I said, since last time you guys released GCC 14.2.0, when this happens, we like to have a release party. We like to say, hey, day one, the Dreamcast, you can come use the latest GCC on Dreamcast. So, yeah, we had a day one party with that. We play with the new features. I will say, we are getting better performance now on the latest GCC for a Tier 3 1999 processor. That's pretty exciting. We have fewer ICEs, but we still have a couple. I'm not going to lie about that. We do have one thing that's a little bit regressed that I should mention. We do use O.S quite a bit in our community, and I'll get into that, to fit into RAM, because we're porting things from like PCs, bigger game engines these days. We use O.S a lot more, and it looks like the binary sizes, while they're getting faster, are getting a little bit bigger since GCC 12.
If you have good examples for it, please open VR.
Okay, absolutely. Thank you. Okay. Okay, awesome.
That's important, have good examples.
Yeah, we absolutely
We
do.
all know that OS request.
Okay.
We all know that, but we need some examples.
Okay.
So we can,
Absolutely. We'll get on that.
yeah.
Thank you. I appreciate it. Oh, and then you guys declared implicitly declared C functions. Thank you. Thank you so much. I know everyone was not happy about that, but I was. Fixed a lot of bad code, especially with LTO. I thought that was a good move. A lot of people were not happy, but I was. C++ 23 features that we immediately got and started playing with. Look, guys, we got a new standard output mechanism. Standard print and standard print line from print.h. Well, not .h, just print. I think they got it from Rust or Python. Doesn't that look like syntactically how their print mechanism works? We also got deducing this, which it's a little complicated, but it helps with representing the curiously recurring template pattern in C++. And another trick that allows you to do that you could never do before is it allows you to recursively call a lambda, which you couldn't do before because you had to have pre-declared the lambda, and yeah, you couldn't identify it. So that fixed that, and we can use all that on the Dreamcast now, which is pretty cool. So that's the output running on the Dreamcast. Next, what we started playing with is in our community, most people aren't writing assembly, but a lot of the people who are at the upper echelons of performance, they either write assembly or there's a fast math library that's been floating around that everyone just copy pastes into their project. And we took a step back. We're like, okay, how fast is this inline assembly here? And so what we have here is this mathematical fast inline assembly that's being used all over the place in the community in different ports. For example, this is in the OpenGL backend for our OpenGL driver. It's fast multiply accumulate. The Super H4 was apparently one of the first ones to have a hardware accelerated FMAC that wasn't for a DSP, and it's only an approximation. So you have to either use inline assembly to do an FMAC, which is A times B plus C. That's all it is. The standard C function FMAF is similar. So we have two scenarios. We have the inline assembly thing that everyone loves to use in our community. And then we have an inverse square root, which I don't know if you guys have heard of it, but Quake 3 had this famous, I don't know how to describe it, integer bit math trick that allowed it to do fast inverse square roots. And there's one instruction on the Dreamcast. So that's another reason we do inline assembly. The multiply accumulate is another one. And then we have this instruction that is a floating point sine cosine pair. You pass it an angle, and then in two different registers you get the sine and cosine, and you can extract that. And that's also an approximation. So to get the compiler to use these, you have to have fast math enabled for obvious reasons. You don't want to apply it across the board. And you have to have two flags enabled that independently enable those instructions, the inverse square root and the combined sine cosine. So we put it to the test. We made a simple example. This is what I see all the time. This is what I saw in our OpenGL driver. We had a static loop that was looping over some preset amount of vertices. It might have been 4 because it was a quadrilateral. Or no, that'd be 6, sorry. Basically, if we define the preprocessor FMAC to 0, we're using this FMAC, which is just, we're letting C. Inline that and do what you can. Otherwise, we're using this thing that everyone's copy pasting in their code base, which is faster. It's one instruction, right? So we finally tested it out, and what do you know? This is C. The compiler decided that it can factor out the multiplication, and that became a constant. And here it loop unrolled, and it became something much worse. It loop unrolled the FMAC, which didn't even ever have to happen. And yeah, so you lose a lot of performance. So this is with a bunch of tweaks. This is Mario 64. Not going to let it play for too long. We thought it'd be boring to just play Mario 64 on a Dreamcast because it should run on a Dreamcast. So this is it at 60 frames per second uncapped to make it more interesting. So yeah, it runs pretty well at uncapped frame rate. There is a little visual glitching on Mario's face. That's an issue we actually fixed, but I kept it because I think it's endearing. That's Dreamcast Mario. Something I thought was really cool is one day I was playing with the new compiler version, and I was like, I wonder what happens in standard C++ if you don't have a time zone database. So I tried to access it, and I had a time zone database on a Dreamcast. And I was like, how did this happen? I could print and walk a time zone database. And it turns out that GCC build script or something added where it will go online and download the time zone database and embed it in read-only RAM, the read-only segment. And yeah, you actually wind up with a time zone database. And you can turn it off too if you don't want it on embedded. So we thought that was really cool. This is our Sonic Mania port, which does a whole bunch of things that are pretty common for the community. This is way too big to fit into RAM initially. We cannot do anything other than O.S initially to fit it into RAM. So what we do is we O3 all of the critical things like the renderers, the graphics, mathematics, the physics, and then we OS everything else, and we kind of mix them to get the best of performance and size. And typically when we do that, we can get the performance as well as running with O3 on everything. So that's pretty nice. We use LTO a whole lot in the Dreamcast community. I always tell people to use it. If you're watching remotely, you should definitely be using LTO. It's like free frame rate gains just for a little bit of extra compile time. And yeah, this is the console logging from the network from Sonic. We had a little fun with C++23, and we made an IRQ handler that can basically be invoked from any generic callable C++ type by making a bunch of concepts that allow you to basically constrain a template argument based on whether it's a callable with the correct syntax or not, and then use any generic callable as a IRQ handler. This is our Doom 64 port to the Sega Dreamcast, which is superior to the actual commercial game in a lot of different ways. We have up to 16 simultaneous dynamic lights. We have bump mapping at target 60 FPS. There's no lighting on the original game. There's no lighting on the Steam re-release, so this has all been added just for Dreamcast. And this, the author, Jan Martin, prides himself on he likes to rip inline assembly out of his code. He just likes to do it in C, like to prove I can achieve this in C, and he absolutely can. Finally, the one that I want to talk about is our Grand Theft Auto port to the 3 ports, the Sega Dreamcast. This was called impossible for like the last 20 years. This was the selling point of the PlayStation 2. You got to buy a PS2 so you can play GTA 3 because the Dreamcast isn't powerful enough. So that was BS. We're going to look at a little bit of code for it. It was a lot of work. It was done by a really talented team. And it was just amazing. The whole Dreamcast community came together and made this happen, and it was beautiful, and we had like 100 players testing, and it was just beautiful. This is just drawing sprites, okay? This is a crazy hybrid C++20 abusing, prefetching, loop unrolling code base that is just mixing modern and old and inline assembly, and it's kind of glorious. It's kind of beautiful. For rendering primitives, there's 2 layers deep of lambdas just to do that, but then we're also being extremely careful with prefetching the cache and doing all that. Believe it or not, just for 2D, these lights, the bloom around it, the lens flare here, the rain, those are all just flat textures, so it's actually important that our 2D rendering was pretty fast. This is something I made on the team. This was born because I wanted to profile the game, but I was too lazy to figure out how the UI worked, and so I decided to render it to the VMU. So we spawn a thread, a standard thread in C++11, and we're able to do a bunch of cool stuff with it relatively easily. That's all the code that took to make that real-time debugger, and we actually released with it. Next, I want to talk about, which in my opinion was the craziest part of this entire project, was the transform and lighting loop. It's the most expensive part of any Dreamcast game because they decided that the Dreamcast CPU would be the thing processing and transforming all the vertices, whereas like the PlayStation 2 used a coprocessor. So this has to be very fast. Just a quick look at it, what we've done is, this is just transformation. Notice we have a bunch of non-template type arguments. They're Booleans. This allows us to basically compile time generate versions of this where we use if const expr and we can compile out the branches, right? So there are multiple instantiations of this loop. None of them have branching in them, and we take the variation, we choose the variation at runtime that is basically best suited. Same with if we're clipping or not, we're prefetching. And yeah, I think it's a little glorious being able to do that on a Dreamcast and mix all those different constructs. This is what it turned out looking like. The audio was a little messed up in this capture because it was earlier in development, so I just turned it off, but you can see that obviously it was possible to run Grand Theft Auto 3 on the Sega Dreamcast. It looks pretty good. It doesn't run as well as the PlayStation 2 yet, but we're still working on it. Has dynamic lighting. It has a pretty high polygon count for that era. It has a lot of special effects, and yeah, it was pretty cool. So what about other programming languages? Sorry, I went too far. I just ruined the surprise. What about other programming languages? Well, we have a couple that are coming up. We have some that aren't complete, but does anyone know what this is? This is the language in case you need to do some government contracting for your Dreamcast or defense programming. And believe it or not, we have a bunch of people who are excited to use this on the Dreamcast because this is apparently related to VHDL, or it took a lot of influence from VHDL, and we have a bunch of programmers who do that. So this is binding to our C API to make OpenGL calls, and this is Ada. And we have the entire Ada toolchain going, the Ada tools, Nat, and all the friends on the Dreamcast now, and we combine it to the C APIs, and I think that was really cool. And that was Mark, so we're very happy with that. And there's a bunch of people who are excited to play with it. Rust on the Dreamcast is in an interesting state because, okay, that's intentional. That's a benchmark. That one is a benchmark, I promise. It's not just bad code gen. But that's our polygon pushing benchmark to see how many polygons can we push. So we actually have GCC RS, and we have Rust GCC RS, and we have Rust C CodeGen GCC, which is the main path chosen for now by the person doing most of the Rust work because it's a little bit further along. It's an experimental CodeGen for the Rust C compiler that interfaces with libgcc JIT. We have full standard library support with it. It integrates with Cargo. We have Tokyo async runtime. We have a bunch of APIs bound to it. There are some that we've made safe, but not very many of them, not yet. It requires patching for SH4. It requires patching for a lot of different platforms that it doesn't technically support. So that's unfortunate. That's a little bit annoying. We've been getting a lot of good use from it, but there are definitely some strengths that we're looking forward to from GCC RS. That's one of them, is it will actually fully support the platforms we have. And there's another issue, actually, that we've encountered. Performance has been really good with this approach, but when it really matters in that transform and lighting loop, this is the critical loop in unsafe Rust for submitting polygons extremely quickly. You send the primitive header, which just tells the GPU what kind of polygon it is, and then for all the polygons, you map to a special buffer that submits vertices to this called a tile accelerator extremely quickly, and you basically commit the vertex. You map to the buffer, fill in the vertex, and commit it. And the way you commit is with, right now, in our SDK, it's with the prefetch instruction inline assembly. That's how the SH4 works. You launch a prefetch with the store queues enabled, and it will basically copy extremely quickly 32 bytes of data, which happens to be your vertex size. What do we have to do with the non-GCC RS Rust configuration? Well, notice this is always inline assembly. They don't have support for SH4 technically, so we can't use inline assembly. So we have to do something a little bit different that you wouldn't think would matter that much, but it does. We have to wrap it in an actual function call. Okay, so think about having to call a function 2 million times a second when this was just one instruction. So actually, that hurts. That hurts us. Wow, the statistics aren't there. Oh, yes, there are. 3 million polygons per second peak with C right now, 2.4 with the Rust bindings, doing literally the exact same thing just because of that function call overhead. So that's something that GCC RS would definitely help with. So looking forward to that. That was kind of the survey of what we've had going on. I want to thank everyone who's contributed to GCC, who's allowed all of this to happen, because it's from everyone's work that we even can have nice things on the Dreamcast still. There's a link for how you get started with Dreamcast development. And I want to mention that we're not the only community that does crazy stuff with GCC. Notice PlayStation Portable, Sega Saturn is SH2. There are CPU cousins. LibDragon, Nintendo 64, they're all on the latest GCC 14. So you guys are powering a lot of homebrew consoles. And we definitely all appreciate that. And we're language enthusiasts, so we definitely use a lot of what GCC has to offer. That was it for the presentation. Are there any questions? Yeah. Thanks.
Did Rockstar ever try to shut down?
That is a really good question. Okay, two things. Obi, who was the lead engineer of the GTA 3 engine, is one of the coolest people I've ever met. He supported us on Twitter and tweeted out that he was impressed and he always thought it'd work on the Dreamcast. And no, we have not been shut down. Every day we look for the cease and desist letter in the mail, and it hasn't. I mean, it hasn't come yet.
Well, shout out to OP.
Yeah, definitely. If you ever see this, thank you very much. Yes.
You say you're from the States,
Yes, I'm from Huntsville, Alabama.
and you show in the picture of your Dreamcast, the logo is blue. It's not blue, it's red.
Yes.
But in the States, the Dreamcast has a blue logo.
No, in the States, it's orange actually.
Yeah, so it's not the same.
Yeah, it's not the same.
You have Japanese or you
I have like 10 different Dreamcasts. Yeah, that must have been. Yeah, I have a little bit of a problem. I have a lot of them in my office. I didn't even notice that. That's really good. That's really perceptive. Yeah, that must have been. That must have been exactly what it is. Yeah, no, that's a good question. Any other questions? Yeah.
How do you port games to there? Like, do you have the source code
Yes.
of the games? Where do you get it from?
Yes, so the question is, how do you port games to there? Do you have the source code to games? Yes, we have to have something to go off of. But fortunately, just like there's a community of us doing Dreamcast stuff, for every big game, really big games, there seems to be communities that emerge that reverse engineer them, that decompile them, and then allow you to port them using our APIs and our SDKs. So these were mostly based on decompilations and reverse engineered projects. And there's more appearing constantly for other games. So that's pretty nice. Yes.
I can just add that the reason why the European Dreamcast has a blue logo is there was a trademark dispute with an Italian company called Tivoli, La Tivola or something like that. And they had an orange swirl, so they changed the swirl to blue then.
I didn't even know the full story. Nice. Anyone else? Okay, well, thank you very much.
Thank you.
Thank you.